Imagine a time when a metal we now use to wrap sandwiches was more valuable than gold. For much of the 19th century, that was aluminum. Emperors and kings coveted this shiny, silvery white substance. Napoleon III of France even had a set of aluminum cutlery for his most honored guests, while others had to settle for gold or silver. Aluminum's value wasn't due to its beauty, but its rarity. Not in the ground, aluminum is the most abundant metal in Earth's crust, but in its pure form. For centuries we simply couldn't extract it. It was locked in rocks, stubbornly bonded to oxygen, making the tiny amounts produced incredibly precious. When the Washington Monument was completed in 1884, its crowning tip was made of aluminum, not gold. At the time it was the largest single piece of cast aluminum in the world. The price? In the 1850s, aluminum cost about $1,200 per kilogram, the same as gold. A bar of aluminum was as valuable as a bar of gold, making it a novelty for the rich and a curiosity for scientists. It was a metal of kings and monuments destined to remain out of reach for ordinary people, until everything changed. The story of aluminum is one of science, scarcity, and a revolution that would transform the modern world. But how did this everyday metal go from royal tables to kitchen drawers? To understand, we need to look at what makes aluminum so special, and so stubborn. Let's dig into the science behind the metal that once outshone gold. Aluminum is an element, symbol Al, atomic number 13, one of the universe's basic building blocks. Its atomic structure gives it a unique set of properties. It's incredibly light, strong for its weight, and doesn't rust like iron. When exposed to air, aluminum forms a thin, invisible layer of aluminum oxide, a microscopic suit of armor that protects it from further corrosion. That's why an aluminum can left in the rain won't crumble into dust. This combination of lightness, strength, and corrosion resistance makes aluminum a wonder material. But for most of history, it was almost impossible to isolate. Hans Christian Ørsted first isolated a tiny, impure lump of aluminum in 1825, but the process was unreliable and produced only minuscule amounts. For decades, producing even a few grams was a laboratory triumph. Aluminum was everywhere in the earth, but locked away, more elusive and expensive than metals thousands of times rarer. The world had a wonder metal, but it was a wonder no one could use. The challenge was clear. How do you unlock a treasure chest when you can't find the key? The answer would require a revolution in chemistry and technology. But first, let's see why aluminum was so hard to extract. The main obstacle was aluminum's powerful bond with oxygen. In nature, it's always found locked in minerals like bauxite. Traditional smelting, heating ore with carbon, works for metals like iron but not for aluminum. Its bond with oxygen is just too strong. Early chemists tried using expensive, dangerous chemicals like sodium and potassium to break the bond, but the process was inefficient and costly. The result, tiny amounts of aluminum at enormous expense. For decades, aluminum was a scientific marvel locked behind an economic wall. The world was full of aluminum, but it remained a precious metal, its potential untapped. The dream of lightweight ships, rust-proof tools, and feather-light structures was just that, a dream. What was needed wasn't a small improvement, but a complete revolution, a new idea that would finally unlock aluminum from its earthly prison. That revolution was about to arrive, from two young minds on opposite sides of the Atlantic. Their discovery would change the world, and the price of aluminum, forever. Let's meet the inventors who made aluminum accessible to all, and see how electricity became the key to the treasure chest. The Hall-Héroult process was about to begin. Here's how it worked. In 1886, Charles Martin Hall in Ohio and Paul Héroult in France independently discovered the same breakthrough, using electricity to extract aluminum. Their process, now called the Hall-Héroult process, dissolved aluminum oxide in molten cryolite and passed a strong electric current through it. The electricity pried aluminum and oxygen apart. Oxygen bubbled away as gas. Pure, molten aluminum sank to the bottom, ready to be collected. This method was elegant, continuous, and crucially, vastly cheaper. The price of aluminum plummeted from $1,200 per kilogram to under $1 in just a few decades. Aluminum went from a precious metal to an affordable industrial commodity. The age of aluminum had begun. Suddenly, the metal of kings was within everyone's reach, and inventors wasted no time putting it to use. Nowhere was this more dramatic than in the race for the skies. Let's see how aluminum helped humanity take flight. With aluminum now abundant, aviation pioneers finally had the material they needed. Its strength-to-weight ratio allowed for rigid, lightweight airframes, far superior to wood and fabric. Zeppelins used aluminum alloys for their massive skeletons, making them light enough to fly. The real transformation came with airplanes. By the 1930s, all-metal monoplanes like the Douglas DC-3 featured sleek aluminum skins, strong, aerodynamic, and weather-resistant. During World War II, aluminum was critical. Planes like the Spitfire and B-17 bomber were built from aluminum alloys. Demand was so high that citizens donated pots and pans to be melted down for the war effort. The lightweight metal that once graced royal tables was now key to air superiority and victory. But aluminum's impact didn't stop in the skies. On land and sea, it would prove just as vital. Let's see how aluminum shaped the machines of modern warfare, and how it became a backbone of military power. Aluminum's lightness, strength, and corrosion resistance made it invaluable for military vehicles, ships, and equipment. Lighter vehicles could move faster, carry more, and be deployed more easily. Aluminum engine blocks and components improved performance without adding weight. Ships used aluminum for superstructures, lowering their center of gravity and resisting saltwater corrosion. Even soldiers' gear, helmets, mess kits, became lighter thanks to aluminum. It was used in radios, munitions, and even explosives. From bombers to battleships, aluminum became a pillar of military power. But after the wars, aluminum's role shifted from conflict to progress. It would help build the world of peace and prosperity that followed. Let's see how aluminum transformed cars and construction. In the post-war boom, aluminum became a symbol of progress. Automakers used it for engine parts, trim, and eventually entire frames, making cars lighter, faster, and more fuel-efficient. High-performance and luxury cars pioneered all aluminum bodies, a trend that continues today. In construction, aluminum's resistance to corrosion made it ideal for window frames, siding, and roofing. Its lightness and flexibility allowed for bold, modern architecture. Sleek skyscrapers and sweeping glass walls. Aluminum was used in everything from ductwork to electrical wiring, quietly supporting the modern built environment. From cars to skyscrapers, aluminum became an unseen but essential part of daily life. But its most remarkable journey was still to come. The metal of kings would soon become the metal of kitchens. Let's see how aluminum found its way into every home. Aluminum's versatility brought it from industry to the kitchen. Its lightness and heat conductivity made it perfect for pots and pans. Easy to handle, quick to heat, and evenly cooking food. Modern cookware is often anodized or coated, combining aluminum's benefits with durability. Aluminum foil, invented by rolling the metal into thin sheets, became a kitchen essential. Flexible, waterproof, and perfect for wrapping food. The aluminum can revolutionize beverage storage, lightweight, strong, airtight, and 100% recyclable. Billions of cans are produced daily, making aluminum the silent guardian of our food and drink. From royal banquets to lunchboxes, aluminum became part of everyday life. But its story isn't over. In the 21st century, aluminum is more important than ever. Let's look at how it's shaping a sustainable future, and why its best days may still be ahead. Aluminum is now at the heart of green technology and sustainability. Solar panel frames, wind turbine housings, and electric vehicles all rely on aluminum's strength, lightness, and resistance to corrosion. In electric cars, aluminum offsets the weight of batteries, making vehicles more efficient. Aluminum is also a champion of recycling, using just 5% of the energy needed to produce new metal. Nearly every can or part can be recycled endlessly, saving resources and energy. As we move toward a cleaner, more efficient world, aluminum is a cornerstone of progress. From rare treasure to daily staple, aluminum's journey is still unfolding. Its unique properties make it a model for a sustainable future. The stubborn element that once outshone gold continues to shape our world, and its story is far from over.